So this video is the one to watch after week 1. So in this video we're going to cover some counting techniques, which for those of you that do have the textbook was section 5.5. So we're going to start this by doing a lead-in example. So we're looking at Applebee's when they offer their 3-course combo. For your 3-course combo, you get to choose an appetizer, an entree, and a dessert. So suppose they offer 2 different appetizers, 2 different entrees, and 3 different desserts. How many possible meals are there that could be ordered? Well, here is what I do know. Each person is going to select an appetizer, an entree, and a dessert. So when we're going through and choosing our appetizer, we could either choose the first appetizer or the second one. Right, so maybe one is chips and salsa and one is mozzarella sticks, for example. So you could choose one of either of those. Now, it doesn't matter which appetizer you choose, you could choose either entree. So if you chose that first appetizer, you could either choose the first entree or the second entree. If you chose the second appetizer, you could choose either the first entree or the second entree, right? It doesn't matter. Finally, we have dessert. It does not matter what appetizer or entree I chose, I can choose any of those 3 desserts, no matter which one I chose for my appetizer or my entree. I get all 3 options. So now if I look at trying to list out what is inside for these options, in a sense I can try to list out my sample space here. I could see one option would be choose appetizer 1, entree 1, dessert 1. So, or 1, 1, 1. I could have chose appetizer 1, entree 1, dessert 2. I could have chose appetizer 1, entree 1, dessert 3. So I could just go through and list out all of these possibilities. And so what I would find when I do that is how many options were there? Well, there are going to be 12 possible meals. So how can I get that without actually having to list them out? Well, why would I want to do that? Well, what if instead there would have been 6 appetizers, 7 entrees, and 4 desserts? This would have got pretty messy pretty quickly by doing a tree diagram. So how can I come up with that 12 without having to list them out? Well, some of you may already know the answer to that, but that leads to our very first rule that we're going to talk about here, called the multiplication rule. So reading that here, so if we have a task, or here like our meal, that consists of a sequence of choices, right? We're choosing an appetizer, we're choosing an entree, we're choosing a dessert. There are P selections for the first choice. P would actually be a number. In our one example, that would have been like we had 2 appetizers. There's Q selections for the second choice. So we had 2 entrees. And R selections for the third choice. So we had 3 desserts. But this could have kept going. So I don't have to only have 3 possible tasks. I could have less, I could have more. So as long as I have to do that sequence of choices. Then the number of ways that we can do all of those choices is just P times Q times R, and we would keep multiplying if there were more of them. So going back to our example here, where did I get that 12? Well, that 12 came from, there was 2 appetizers, 2 entrees, and 3 desserts. So that's where I'm getting that 12. So how would this apply to our one down here? So what if there were 6 appetizers, 7 entrees, and 4 desserts? Well, then I would just take the 6 times the 7 times the 4 to get me 168 different possibilities there. So that's how our multiplication rule works. Let's try it for a couple more examples. So we just did the one here for our new 3-course combo. So we had our 6 appetizers, our 7 entrees, and our 4 desserts to give us that 168 possible meals. For another example, how many different sets of initials are there for first and last name? So we're just going to have a first name and a last name. How many options for your first initial? Well, there are 26 letters in the alphabet. How many options are there for your last name? Well, there's also 26, because you could have the same letter for both. And then we're just going to end up multiplying those because we're getting a first name and a last name. So this would give us a total of 676 possible combinations for first and last name. As an aside, I'm going to write this down, because you already see me doing this multiplying a lot. And one of the biggest times we're going to be using this multiply is when we have this idea of and. So I'm going to pick an appetizer, an entree, and a dessert. I'm going to have a first and last name. Because we're going to see when we're not doing and, we're not necessarily going to be multiplying anymore. Right, another example. So out of 8 swimmers, how many different ways could we give a gold, silver, and bronze medal? So for our gold medal, so we have 8 people out there racing. How many different people could touch for first place? All right, any of the 8 could choose to select first, and so we have 8 different options for gold. Now how many options are there for silver? Well, you can't win more than one medal, so after that first person got gold, there's only 7 people left to get silver. So now that we have gold and silver chosen, there's 6 people left who could get bronze. And since we're doing a gold and a silver and a bronze medal, we're multiplying all those numbers together to get us 336 possible options. So there's our multiplication rule. Next, we're going to be talking about permutations and combinations. So in order to understand those, one of the first things we have to talk about is this factorial symbol, or when you see this exclamation point. So when you see n factorial, where n is going to be a number, you take n times n minus 1 times n minus 2 and keep doing that until you get times 3 times 2 times 1. So for example, if you're trying to find 8 factorial, you're going to take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And doing that, we would get 40,320. So one thing we might want to do first is make sure you can find that on your calculator. So in your scientific calculator, you're going to find generally these 3 keys together, this NPR, the NCR, and the exclamation point. Often it's under a probability function, or can sometimes be where you have to hit second before you can get these values to occur. If you're ever having problems finding these on your calculator, just come talk to me and I will help you find them. So here's the exclamation point, which is our factorial. So if I do 8 factorial, we get that 40,320 that I just showed you. Now the reason we wanted to talk about factorials is because those show up in both permutation and combination formulas. So permutations and combinations are very similar. They have one small difference. So be sure to make notes as we're going through these ideas. So a permutation is an ordered arrangement and where there's R total objects, R objects are chosen from N total objects. So R is the number you're choosing, and N is your total number. And repetition is not allowed. Right, so these objects have to be different. So for example, if I had different people, they would be different. What the repetition is not allowed means is once you're chosen once, you can't be chosen again. That's just what that part means. Ordered is important in the fact that what that would mean is if I'm choosing 2 letters from the alphabet, if I chose A and then B, that would be different than choosing B first and then A. So they're ordered. So AB would be considered a different outcome than BA. So how I find the number of permutations is we have this NPR key that we're going to use, but I'd like you to also know where that is coming from, is it's n factorial over n minus r factorial. There's actually a problem from above that we could actually use this for. Let's go back to this swimmer's example. So we do care about order, because right, if you touch first you get gold versus if you touch second you get silver. So that definitely means that order is going to matter to us. We're choosing 3 people from a total of 8, and the same person can't touch more than once. So what that would mean is using that same swimmer's example, I could also use a permutation on it. So that would mean that I would want to do 8 permutation 3. First, we're going to write out what that is just so we actually understand that. So that's 8 factorial over 8 minus 3 factorial, which then is 8 factorial over 5 factorial. And so if you actually write out what each of these factorials are, you're going to see the nice simplification to get what we already did. Right, so we just end up at this 8 times 7 times 6 that we did above to get that 336. Now, how do we put that into our calculator? So we're going to hit 8, then we're going to hit that NPR key, and then we're going to hit 3. So I'm going to do 8, NPR, 3, and hit enter. At least that's how you would enter it on your calculator. This one's acting a little bit different. So in this calculator, we do actually have to enter it a little bit different. But again, in yours, generally you have to hit 8 first, then the NPR key, and then 3. Here I'm just going to show you that we're going to get the same thing. And you see that we do get that 336. So now let's talk about how a combination works. So a combination is a collection where we do not care about order. So that's our first and only important distinction here between a combination and permutation. We do not care about order. R is still the number of objects we're choosing, and N is our number of total items that we have. And they still are different objects, and still repetition is not allowed. So now to do combinations, it's this NCR key, and it's n factorial over n minus r factorial times r factorial. So you'll notice the main difference here is the additional r factorial on the bottom is there for a combination that's not there for a permutation. So what that is doing is getting rid of all of those duplicates. what this actually then means for us, if I was again choosing two letters of the alphabet, if I were to choose the letter A and the B, that would be considered the same thing. It would not be different than B and then A. So in a sense, as long as I got chosen, that's all that matters to me. I don't care what order I was chosen in. That's what a combination would mean. So let's go through and actually do some examples that we would have to either apply the multiplication rule, a permutation, or a combination to. So we can see why we would use one rule over another. So we're going to start by having a group of 6 individuals. We want to figure out how many different ways they could form a 3-person committee. So I know I'm going to choose 3 people. So I have these 3 spots. First question I'm going to ask, are the spots different or are they the same? That is, does it matter if I was chosen first, second, or third, or doesn't matter? Well, if I'm on a 3-person committee, I'm on a 3-person committee, whether I was the first person, second person, or third person chosen. So for that reason, they're the same. What that's going to tell me then is that order does not matter. Can I choose the same person more than once? No, I mean I can't have a 3-person committee made up of Jackie, 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 right? That isn't, the same person can't serve all 3 roles. I do need 3 different people. So repetition is not allowed. So this then is leaning me toward a combination, because order does not matter. Repetition is not allowed. So how many total people am I choosing from? How many am I going to choose? So I then just want to do 6 combination 3. And we're going to get 20 for our answer. Now instead, suppose I want to figure out how many ways they could elect a president, a vice president, and a secretary. So again, 3 spots. Asking myself that same question, are the spots the same or different? Well, here, they're actually going to be different, right? Because one is a president, one is a vice president, and one is a secretary. So if I'm president and you're vice president, that's different than if you're president and I'm vice president, right? Even though we were both chosen, we care which spot we got. Still, same thing, that repetition is not allowed. So this time, since the spots are different, that tells me that order does matter. So now I'm going to be using a permutation. Where my N is 6 and my R is 3. So that's going to give us 120. So notice for this example, the only thing that was different between part 1 and part 2 is that order mattered in the second part, but not in the first part. So what should we notice? There are more ways of ordering those 3 people than to not order those 3 people. Now, for this one where I did a permutation, could I have used the multiplication rule? The answer is yes. How would I have used the multiplication rule? If I were to use the multiplication rule, I would say, well, 6 different people could have filled the president, Once the president is chosen, there's only 5 people left that could serve as vice president. Once both the president and vice president are chosen, there's only 4 people left that could serve as secretary. So that will give me 120. Add a little note though. So if you do a permutation, you could also do the multiplication rule. However, the same is not true the other way around. So if you could do the multiplication rule, doesn't mean you can do it as a permutation. Now, why? Well, let's go back and look at our one example here where we chose the letters in our names. In order for a permutation to have worked there, repetition would not be allowed. That would mean that you cannot have the same initial for first name and last name, that they would have to be different. That's not true for first and last name. You can have the same first and last initial. So that's an example where we would have to use the multiplication rule and could not use a permutation for it. Right, we have another example that we're going to do for this video. So suppose that we have 2 tickets for an upcoming concert and 5 friends who want to go. How many different ways could you invite 2 friends if your friends care which seat they got? So how many friends do we have? 5. How many are we going to choose? 2. Right, repetition is not going to be allowed here. Why? We're not going to invite the same friend for both tickets. We have 2 tickets. We're going to have 2 different people go. Does order matter? Yes, they care which seat they got. Right, they care which seat they got. So for that reason, this one's going to be a permutation. We're going to have 5 total people to choose from. P, since the order does matter, and our 2. So we're going to get 20 for our answer. Now if instead they're general admission tickets, this first stuff is still the same. I still have 5 friends. I'm still going to choose 2 of them. Repetition is still not allowed. But now, because I have general admission, does order matter? No, because they're general admission, right? So the tickets are the same. There's no difference between them. So for that reason, this one is a combination. So this time we're going to have 5 combination 2. We know that this answer should be smaller. Remember, there's more ways to order something than to not order it. And we get 10. So re-look over these examples yourself, see if they make sense. The good news is next class we're starting by doing some more examples of trying to understand when we apply each of the multiplication rule, combinations, and permutations.